guys, I hope you guys are doing fantastic. Today I want to get into the topic finance, growth, and decay. I want to get into this particular topic. So this over here, this particular topic is going to be for grade 11 and grade 12. Right, it's going to be for grade 11 and grade 12. And then in the next video, which I'm going to just post the link to, it's going to be specifically for grade 12. So from this particular topic, finance, growth, and decay, we can already see that the topic is divided into three. So I'm going to start off with growth. Right. So growth, which is the increase in the value. The increase in the value. So this particular increase could be the increase in the value of an investment. It could be the increase in the value of a savings account. Right. So this increase in value occurs in two ways. It occurs via simple interest, as well as compound interest. Okay, cool. Now there's a difference between these two ways in which money can grow. Right. Simple interest, we use the formula A equals to P into 1 plus I multiplied by N. While on the other hand, compound interest is A into P 1 plus I to the power of N. Actually, I'm just going to do it like this, over M to the power of N multiplied by M. So now let's get into what each of these variables mean in the formulas. A is called the accumulated value. This is the value of your investment after it has grown, right? After it has gained interest. And then we have P, which is the principal value. This is the initial value of your investment, the one that you put in. And then I is your interest rate. It is always represented as a percentage. And then N is the number of years. Right. So these very same definitions still apply in the compound interest formula. A is still the accumulated value, P is still the principal value, I is still the interest rate, N is still the number of years. The only difference is that for the compound interest, we have M over here. M stands for the compounding period. It's the compounding period because we're dealing with a compound interest. So the compounding period is how many times interest is gained. How many times interest is gained. Right. So now interest could be gained annually, which means once a year. So your M is going to be 1. Interest could be gained semi-annually, which means twice a year. So your M would be 2. Or it could be gained quarterly, which means 4 times a year. So your M is going to be 4. And then lastly, interest could be gained monthly, which means 12 times a year. So your M will be 12. So depending on the compounding period, how many times you gain interest, your M is going to be a particular value, and then you're just going to replace it with that. So that is growth, simple interest, and compound interest. Now let's get into compound interest. What are the other uses of compound interest? Other uses of compound interest. What can we use compound interest for besides growing money? It can be used for inflation. Inflation is the increase in the price of goods and services. The increase in the price of goods and services. So we use this particular formula as well, the compound interest formula, but then without the compounding period. So in this way, A would be the price after inflation, and then P would be the price before inflation. I would be rate of inflation, and N would be the number of years. So that is inflation, one of the uses of a compound interest formula. Now the second one is population growth. This is when the number of people in a particular area increase. The number of people in a particular area increase, that is population growth. So we use the compound interest formula to calculate the changes that happen during that situation. A is the number of people before growth, or rather, number of people after growth. After growth happens, A is the number of people after that, and then P is the number of people before growth. While I is the rate of growth, it's always represented as a percentage. Even inflation, the rate of inflation is always represented as a percentage. While N, on the other hand, is the number of years. Notice that in these uses of the compound interest formula, there is no compounding period. So these are the other uses of the compound interest formula. These are the other uses of the compound interest formula. Inflation, which is the increase in the price of goods and services, and population growth, which is the increase in the number of people occupying an area. Okay, cool. Now, graphically, if we would draw the graph representing compound interest and another one representing simple interest, our graphs would be like this. Okay, so over on the y-axis, it's going to be my A, and over on the x-axis, it's going to be N. Y-axis is A, x-axis is N. For the simple interest, growth happens in this way. It goes up in a straight line, while for compound interest, growth occurs as an exponential graph, like this. Right. So this is simple interest. A equals to P into 1 plus I multiplied by N. This is compound interest. A equals to P 1 plus I to the power of N. And another thing, this y cut over here is our principal value. Where it cuts the y-axis is our principal value. Right. So that is growth. Decay, often called depreciation. Decay or depreciation. This is the loss in value. This is the loss in value of items. We understand that as soon as we buy something from the shop, it loses value, right? If you buy your phone, the moment you buy it from the shop, you take it from the shop, it loses its value, right? You will not sell it with the same price that you bought it for. Now, this loss in value, this depreciation occurs in two ways. It occurs in the straight line depreciation, sometimes often called linear depreciation, or it could happen via the reducing balance method. Right. Okay, cool. So now the straight line depreciation is A equals to P into 1 minus I multiplied by N, while the reducing balance method is A equals to P into 1 minus I all raised to the power of N. Now, over on depreciation, A, P, I, and N, they mean different things, right? A over here is called the book value or scrap value. When you hear the word scrap, you know that we're dealing with something that has lost its value. So it's the price of your item after it has undergone depreciation, after it has lost its value. That is A. And P is the initial value. P is the initial value, while I is the rate of depreciation. Rate of depreciation, while N is the number of years. The number of years. Right. Okay, cool. So this applies for both the reducing balance method and the straight line depreciation. Right. Okay, cool. Now, graphically, if we were to represent these two concepts on a graph, right, we would have something of this nature. This one over here, which will draw for the linear. This one over here will draw for the reducing balance method. Right, remember we're losing value. So over here, this would be our book value over on the y-axis. And then this will be the number of years, our book value on the y-axis, number of years. Okay, cool. So our two graphs would be for linear depreciation, linear, which is A equals to P into 1 minus I multiplied by N. And this would be our graph. Right. And then for reducing balance method, which is A equals to P into 1 minus I all raised to the power of N. This would be our graph. Right. And then this y-intercept over here would be our P. This over here would be our P, our initial value. So these are the two concepts of decay represented as graphs. Now, I just want to go over on the reducing balance method a little bit so that I can give out other uses of reducing balance method. It's not only used when items lose value, it can also be used for other things, particularly just one particular thing, right? It can be used for population decline. Population decline. This was when the number of people occupying an area goes down. It could be because of natural causes like death, or it could be because of migration. It could be because of natural causes or migration, but then essentially population decline is the number of people in an area reducing. So it happens via the reducing balance method. So in this case, A is the number of people after decline, meaning after they go down in number. And then P is the initial number of people before decline. Before decline occurs. And then I is your rate of decline. It's always a percentage. And then N will be your number of years. So that is decay in a nutshell. Okay, cool. Now, there is also nominal interest and effective interest. Nominal interest and effective interest. Nominal interest versus effective interest. So nominal interest is interest that takes into account the compounding period. It takes into account the compounding period. While the effective interest does not take into account the compounding period. Doesn't care whether interest is monthly, is earned monthly, quarterly, semi-annually. The effective interest does not care. While on the other hand, the nominal cares. So now what we do with the nominal and the effective interest is that we change one to the other using this formula over here. 1 plus I effective equaling 1 plus I nominal over M, which is the compounding period, raised to the compounding period. So this is the formula for us changing from effective interest to nominal interest. Now, one notable thing about financial maths is that we also need to account for a timeline. So a timeline, we're going to delve into it using a question, because most of the time a timeline is very simple when you have a question in front of you, so that you can explain each and everything that you need to explain, which will cover up all the questions for timelines. So look out for the timeline question in the other video, which I'll just put on the screen. Thank you.